Not a new pharmaceutical breakthrough, not a billion-dollar research program. A plant, one single plant, that has been fighting infections across 4 continents for thousands of years. And in 2018, scientists confirmed its leaf extracts outperformed hospital-grade disinfectants. This is not theory. This is published science. Before we go any further, this content explores emerging research and traditional knowledge. It is not medical advice. Always consult your healthcare provider. If that is the kind of content you value, subscribe right here and turn on notifications. Now, in 1945, Alexander Fleming stood before the Nobel Committee and delivered a warning. He said the miracle of antibiotics would not last forever. 80 years later, his warning has come true. Today, more than 1 million people die every single year from infections that no antibiotic can stop. MRSA deaths alone have doubled since 1990, from 57,000 to 130,000. And according to The Lancet, by 2050, 39 million more will die. That is more than cancer and heart disease combined in some regions. What if the most powerful weapon against superbugs was growing through the cracks in your sidewalk? Your grandmother might have called it by a different name. In some communities, mothers have been passing this knowledge down for generations. Not from textbooks, not from prescriptions, from the garden, across 4 continents. For thousands of years, traditional healers understood what nature provided. In the Americas, as early as the 16th century, colonizers documented indigenous peoples using this plant for wounds, infections, and dysentery. They did not understand why it worked, but they saw that it did. In China, healers have been using it since the 7th century. They called it Xian Fang Cao and prescribed it for enteritis, dysentery, and pharyngitis. In Japan, it became a medicinal tea for inflammatory skin conditions. In Africa, the story is the same. In Uganda, it was used for wounds. In South Africa, for headaches, malaria, even as a poison antidote. In Kenya, they called it micha and used it as both food and medicine. In Vietnam, soldiers carried it into battle. They called it soldier vegetable. Now stop and think about that for a moment. 4 continents, thousands of years, dozens of cultures that never communicated with each other, all independently discovered the same plant and used it for the same purpose. What did they know that we have forgotten? And here is where this story takes a turn that nobody expected. In 2014, a team of scientists in Brazil decided to put this ancient wisdom to the test. They took leaf extracts from this plant and placed them against the most feared superbug in hospitals today, MRSA, methicillin-resistant Staphylococcus aureus. The results? Every single strain fell. 60 out of 60. What your grandmother knew, science just confirmed. 4,000 years late. Let us talk about what the research actually shows. Because this is not just one study. This is a pattern. That 2014 study from Brazil, it did not just show that the plant worked. It showed that leaf extracts achieved a mean inhibition zone larger than chlorhexidine at 0.12%. That is the gold standard disinfectant used in hospitals around the world. A plant growing in sidewalk cracks outperformed the disinfectant that surgeons trust before surgery. But here is what makes this even more remarkable. In 2018, researchers tested it against waterborne bacteria. The minimum inhibitory concentration ranged from 0.6 to 10 milligrams per milliliter. Effective, consistent, reproducible. In 2021, another team tested it against sexually transmitted bacteria, active against Neisseria gonorrhoeae, active against Gardnerella vaginalis, active against Candida albicans, and the list keeps growing. Pseudomonas aeruginosa, the bacteria that sends burn victims to the emergency room, active. Klebsiella pneumoniae, one of the most dangerous hospital-acquired infections, active. Bacillus subtilis, aquatic pathogens. The evidence stretches across dozens of peer-reviewed studies. Now, you might be asking yourself, how? How can a single plant fight so many different types of bacteria? While conventional antibiotics target bacteria through one or two mechanisms, this plant uses multiple pathways simultaneously. That is what makes it so different. That is what makes bacteria struggle to develop resistance against it. And the scientists were asking the same question. So they took a closer look at what is actually inside this plant. What they found changed everything. 201. That is how many active compounds scientists have identified in this single plant. 70 aliphatics, 60 flavonoids, 25 terpenoids, 19 phenylpropanoids, 13 aromatics, 8 phthalins, and the list goes on. Think of it as a 201-member army. Each soldier attacks bacteria from a different angle. Some disrupt cell membranes, some inhibit the COX pathway, others interfere with quorum sensing. The communication system bacteria use to coordinate attacks. Some bind directly to bacterial DNA. Others shut down energy production and protein synthesis. That is why bacteria cannot develop resistance. They cannot fight an army that attacks from every direction at once. And here is something that even the scientists found remarkable. Some of these compounds, polyacetylines, are activated by ultraviolet light, sunlight, which means when traditional healers crushed fresh leaves and placed them on a wound in the sun, they were unknowingly triggering a chemical activation that modern science only just discovered. Ancient wisdom, validated by molecular biology. The evidence does not stop in the laboratory. In 2017, researchers tested this plant against E. coli. The result? An 18.2 millimeter inhibition zone at just 10 milligrams per milliliter. Compare that to ampicillin, one of the most commonly prescribed antibiotics in the world, which was tested at 30 micrograms per milliliter, competitive with a pharmaceutical antibiotic at a fraction of the concentration. But what happens when you move from the lab to the kitchen? In 2016, a meat preservation study found that extract from this plant outperformed BHT, a synthetic preservative used in processed foods worldwide. Over 6 days of testing, it was more effective at reducing total viable bacteria and lactic acid bacteria. A plant preserving food better than a chemical designed in a factory. The evidence is overwhelming. The plant works. 4 continents knew it. Modern labs confirmed it. Dozens of peer-reviewed studies support it. So if the evidence is this strong, if thousands of years of traditional use are now backed by modern science, then why has this plant been classified as nothing more than a weed? Here is the answer, and it has nothing to do with whether the plant works. You cannot patent a wild plant. You cannot patent indigenous knowledge from 4 continents. and you cannot create a synthetic analog that beats 201 synergistic compounds working together. Think of it as discovering the world's most powerful free medicine, and then being told there is no profit in it. That is the reality of plant-based antimicrobials. Between 1960 and 1980, the world experienced what scientists call the golden age of antibiotic discovery. New drugs were being developed rapidly, but after 1980, that pipeline began to dry up, and something else happened. The pharmaceutical industry shifted. According to industry analysts, the focus moved from antibiotics, which you take for 7 to 14 days, to chronic disease medications, which you take every day for the rest of your life. The economics are simple. Daily medication generates recurring revenue. A 7-day antibiotic course does not. Today, it is not the major pharmaceutical companies leading novel antibiotic research. It is small biotech firms. And according to public records, fewer than 50% of new antibiotics are available in more than 10 countries worldwide. The system was not designed to suppress this plant, but it was designed in a way that made it almost impossible for this plant to succeed within it. And the barriers go even deeper than patents and profits. Running clinical trials on botanical compounds is expensive and incredibly complex. This plant contains 201 active compounds, and their concentrations vary depending on where it grows, when it is harvested, and how the extract is prepared. Standardization, the foundation of modern pharmaceutical approval, becomes a monumental challenge. How do you standardize something that nature designed to be variable? Scaling from laboratory results to commercial production introduces even more uncertainty. And without the guarantee of exclusive rights, there is little financial incentive to invest hundreds of millions of dollars in trials. The regulatory system was built for synthetic molecules with predictable behavior, not for a wild plant with 201 moving parts. But here is what they did not count on. The plant does not need a patent. It does not need a prescription. It does not need approval from anyone. It just keeps growing. In sidewalk cracks, in empty lots, in your backyard. It has been doing this for 4,000 years, and no regulation has been able to stop it. Right now, in hospitals around the world, families are being told the same thing. We have tried every antibiotic we have. There is nothing left. More than 1 million people hear some version of this every single year. The bacteria have evolved, the antibiotics have not, and the system designed to protect us has shifted its focus to drugs you take every day for the rest of your life, because that is where the money is. The numbers are devastating. According to the 2025 Global Antimicrobial Resistance Surveillance Report, more than 23 million confirmed cases were recorded across 110 countries. Carbapenem-resistant infections, once considered a last resort treatment, have seen deaths rise from 127,000 in 1990 to 216,000 in 2021. Third-generation cephalosporin-resistant enterobacterales now sit on the World Health Organization's critical priority list. And here is perhaps the most heartbreaking statistic of all. 80% of countries have extremely limited access to even first-line antibiotics. More people are dying from lack of access to antibiotics than from resistance itself. 169 million deaths are projected between 2025 and 2050. The Lancet estimates that simply improving access could prevent more than 50 million of those deaths. But what if the answer was never in a lab? What if it was growing in the soil beneath our feet, waiting for us to remember? In the West, this plant was classified as one of the world's most common weeds. Agricultural extension offices published eradication guides. Herbicide companies sold products specifically designed to kill it. Homeowner associations prohibited it from growing in front yards. But halfway around the world, something remarkable was happening. In China, it remained a mainstream traditional herb used in clinics to this day. In Mexico, mothers were feeding its young leaves and flowers to their families for stomach ailments, hemorrhoids, and diabetes management. In Africa, it was both food and medicine, used for infections, inflammation, and wounds. In India, traditional practitioners were using it for wounds, colds, flu, hepatitis, and urinary tract infections. Half the world never stopped using this plant. They did not need a clinical trial to tell them what their ancestors already knew. They did not need approval from any agency. They did not need a pharmaceutical company to put it in a bottle and sell it back to them. And now, with 201 bioactive compounds confirmed, with studies showing it can fight the very superbugs that modern medicine cannot, the science has finally caught up. The irony is staggering. While one half of the world was writing eradication guides, the other half was eating it for dinner and using it to support their family's well-being. So, here is the question. If this plant is so remarkable, how do you find it? How do you know what it looks like? And how do you use it safely? This plant is an annual herb, typically growing between 30 and 100 centimeters tall. It has bright green leaves with serrated edges, arranged in pairs along the stem. At the top, you will find small yellow flowers surrounded by white ray florets. And here is the most distinctive feature of all. Its seeds, small, black, with tiny barbed bristles that stick to your clothing, your socks, your pet's fur. If you have ever walked through a field and come home covered in tiny black seeds that refuse to let go, there is a very good chance you already know this plant. Now, an important note. Do not confuse this with plantain, purslane, or black seed. These are entirely different plants with entirely different uses. The key identifier: barbed black seeds that stick to clothing. If the seeds do not stick, it is not the right plant. It grows in disturbed soil, agricultural fields, urban waste areas, roadsides, and empty lots. It grows where people live. It costs nothing. For harvesting, look for young leaves and flowering tops. Always collect from clean soil, away from roads, chemical runoff, and areas where pesticides may have been applied. There are several ways to use this plant. You can eat the young leaves raw, though they have a slightly resinous taste. You can cook them like spinach, add them to soups and stews, or dry them for tea. For a traditional decoction, take 1 to 2 teaspoons of dried aerial parts. Bring water to a boil, add the plant material, and let it simmer for 10 to 15 minutes. Strain and drink. Traditional practitioners suggest up to twice daily. But before you try anything, listen carefully. Always consult your healthcare provider before trying any new herb, especially if you take prescription medications. Pregnant or nursing women should avoid this plant. Start with a small cup of tea once a day. Traditional practitioners Recommend using it for no more than 2 to 3 weeks at a time before taking a break. Now, let us step back and look at the full picture. We have an industry that cannot profit from what grows free. We have a regulatory system designed for synthetic molecules, not for plants with 201 compounds. And we have a medical establishment that stopped looking at plant-based antimicrobials the moment penicillin arrived. Meanwhile, more than 1 million people die every year from drug-resistant infections. That number is projected to rise by 70% by 2050. And a plant that fought alongside humanity for 4,000 years was classified as a weed. Perhaps the answer was always there, growing quietly in the soil beneath our feet, waiting for us to remember what nature provided. Its name is Biden's pilosa. Now I want to hear from you. Have you ever seen this plant growing near you? Or have you already used it? Drop a comment below. And if you learned something today, share this with someone who needs to hear it. Subscribe right here so you do not miss what is coming next.